Hi Geometry, here I am cranking out the third video of the night. Let's see how many I can get done. Here we go, 11.3 areas of a regular polygon. Okay, so now we're going back to the polygons that we talked about. However, remember last chapter was primarily quadrilaterals, but here we go. I can find the areas of regular polygons, so even though I might not have put the word regular in, that's kind of what I mean, inscribed in circles, so inscribed means inside, and I can apply these problems in real life situations. So here we go. An isosceles triangle has the lengths. Okay, recall what an isosceles triangle is. Two lengths are the same, 20 and 20. Oh, no. 20, 26, 26. See what happens if I don't read it carefully? Okay. Find the length of the altitude to the base. Okay. All right, so recall the altitude of an isosceles triangle. We'll cut that in half. So actually, I have a right triangle that looks like this. And we'll just put A for altitude. This 20 is cut in half, and that's 10. So I have A squared plus 10 squared is equal to 26 squared. So I have A squared plus, no, we'll just go ahead and go to subtract 100 on both sides. We're going to get 576. And then take the square root. A is equal to 24. Alright, I'm just trying to, I realized how much space I was taking. Sorry about that. How about this one? Solve. I need x by itself. It's being multiplied by a fraction. So to get rid of a fraction, multiply the reciprocal. So if I multiply this side by 2 over 1, multiply this side by 2 over 1. 2 times 18 is 36. Because these will cancel. So x is 36. How about this one? Evaluate. Oh, again, I have this calculator. Let's see here. 4 cosine of 10 degrees. Oop. Let me try this. 10 cosine times 4. There you go. So I have to do 10 cosine times 4 with this little this cheap calculator. Alright, so that turns out to be about 3.939. And so now I need 20 sine times 10. And that's about 3.42. Multiply them. You're going to get 13.471. Okay, and if you look at this calculator, does say degree. I don't know if you could see that. So I wonder why it's so fuzzy. It's not very clear. Wonder, yeah, old model. I saw that there's this on sale for like $500. I'm like, yeah, I really don't want to buy a new one. All right, 10 divided by 88 tangent equals 0.3492. All right, so yeah, we might have to do a little bit of trig in this section. Hopefully you remember some of that. Here we go. And where's my highlighter? We're going to use purple. The diagram shows a regular polygon inscribed a circle. Okay? So that means the polygon is inside. If it was circumscribed, it would be outside the circle. The center of the polygon and the radius of the polygon are the center of the radius of its circumscribed circle. Spelled that wrong. So the distance from the center to any side of the polygon is called the apothem. So from here to here, and notice I had to abbreviate it, A-P-P-O-T-H, apothem. The apothem is the height to the base of an isosceles triangle that has two radius of the legs. Okay, so the radii will be the same, so they have to be congruent. Makes sense, right? Because they're going to the edge of the circle, and that will be the height. Central angle of a regular polygon is an angle formed by the two radii drawn and two consecutive vertices. Okay, so that means this angle right here is your central angle. Got it? Okay, to find the measure of each central angle, divide 360 by the number of sides. Okay, because think about it. If I look at this one, I have 1, 2, 3, 4, 5, 6. If I take 360 divided by 6, I'll get 60 degrees. So each one of these would be 60 degrees. That makes a full circle. Okay, so let's look at example 1. We have a regular octagon is shown. Find each angle measure. Okay, so measure AOH. So I need this angle right here. AOZ. I need this angle right there. And then ZHO. Okay. Oop. AOZ would be this part right here. Sorry, I'm a mess. All right, so here we go. So angle AOH. Remember, right up here, divide 360 by the number of sides. So 360, how many sides are an octagon? 8. Divide by 8, 45 degrees. Why am I using my highlighter color? Okay. How about AOZ? AOZ, it's going to be half of that. Remember, this cuts that isosceles triangle in half. So that would be 22.5 degrees, half of 45. And then, excuse me, these are the measures. Measure of angle ZHO. ZHO, that's this one. Okay, now let's think about it. I have an isosceles triangle, and if I take 360 minus 45, divide by 2, I should get that answer, right? So 360 divided by 45, sorry, not, so 3, I messed this up, 360 minus, I'm a mess, 180 minus 45 divided by 2. Let's see what we get. 180 minus 45 divided by 2. 67.5. Okay, now let me show you what I did before, and I just thought that was kind of weird. So look what I did. I took n minus 2 times 180. Remember that? The sum of the interior angles. That means each one of these angles is 1080. Then I divided by 8. So when I took the 1080 divided by 8, I got 135. So that means this whole angle is 135. So I only wanted half of it. Divide by 2. So that was the other way. So I recommend write that down. Here's another way to do that problem. Pause this and write that down. I thought it was kind of clever. I'm actually surprised I did the problem that way when this was just as easy. Remember, you have an isosceles triangle, all three angles up to 180. Take 180 minus the 45, divide it in half, because each of these would equal that. All right, page 2. Hopefully I don't make so many errors. I have the answers right in front of me. You gotta love it. Okay, area of a regular polygon. The area of a regular n-gon, okay, how many sides, I don't know, with the side S is 1/2 the product of the apothem and the perimeter. So A is equal to 1/2 the apothem times the perimeter, or A equals 1/2 A times NS. Okay, let's see here. So for instance, this hexagon has 6 equal triangles. I'll just put congruent triangles. All right, find the area of one triangle. Then multiply by 6. So we know area of a triangle is 1/2 base times height. So 1/2, your base, if we just call this S, times your height, that's your height, and then times N. And here, N is equal to 6. So that's where I get that. Our height is basically your apothem, okay? N is number of sides, S would be that base. So, all All right, now, how come this one has an A, then P, and this has N times S? Well, N would be the number of sides times S. Number of sides times S would be your perimeter. Okay, so that's the same thing. This is your perimeter. But I want you to keep that in mind. If you forget these two formulas, just do each triangle, multiply by how many triangles you have. Okay, you are tiling a floor with ceramic regular hexagons. This is a new trend, okay? So tell your parents about putting up a new backsplash in the kitchen. So with side length 8 inches, what is the area that a tile will cover? All right, so we have hexagons. Let me see if I can draw a really nice hexagon. Oh, not bad. And the side length is 8. All right, so first of all, I know that this is, we have each one of these. I have 6 triangles, 1, 2, 3, 4, 5, 6, and the whole circle is 360. If I take 360 divided by 6, this is 60. So this is an equilateral triangle because this is the same. So we have 60, 60, 60. And if I cut it in half, this is our 60, and that's our 30. Remember, this side length was 8, so I just cut that in half, put a 4 here. What do we have here? Remember, x, 2x, x squared of 3. Okay, so this is going to equal 8, and this will be 4 times the square root of 3. That's my apothem. Or you can say like the height of that one triangle. Alrighty, so area of the triangle is 1/2, your whole base is 8, times your apothem, 4 times the square root of 3. Okay, half of 8 is 4, so 4 times 4 is 16. Now that was just for one triangle. Take 6 times 16 times the square root of 3. You're going to get 96 times the square root of 3. Of course, that doesn't help you, if you just put it in the calculator. 166.3 inches squared. Of course, notice I still use this method up here, like figuring out in my head how to find the area, because these little simple formulas I will forget. But if you practice them, it works out nicely. Okay? Now, again, instead of thinking of the interior angles are 360 divided by 6, I get 60 here. I did it. Or you could have done, find one of these angles. Remember, n minus 2, n is the number of sides, so 6 minus 2 times 180, you're going to get 720. Divide by 6 for each one, you get 120. So that's the other way to find it. Next one. A regular decagon, that's 10 sides, okay, is inscribed in a circle with a radius of 8. So now the radius is 8. Find the perimeter and the area of the decagon. Okay, so if I remember, we have, like 10 of these. And if I just take 360 divided by 10, I'm going to get 36. So that means this angle right here is 36. And this is all these triangles are always going to be isosceles. So that means the base angles are 72. How do I know? 72 plus 72 plus 36 is 180. Now another way we could have done this, n minus 2 times 180 is equal to 1440. Then divide by the number of sides you have. You get 144. Okay, so that means this angle right here, this whole angle, we'll just mark this one, is 144. So if I cut it in half, that would be 72. All right, let's go ahead and use the formula. Area is equal to 1/2 A N S. Ooh, I gotta find A, don't I? So there's a lot of calculations going on here. 72, I cut this in half, okay, right down the middle. This 36 is now 18. Kind of wish I had a special triangle for this, but I don't. So I know that this is going to be 8. How do I find this length? Maybe a little trigonometry. Okay, so this is the hypotenuse, this is adjacent, so this is kind of like our half side length. Or actually, let's find A. Let's find A first, our apothem. So to find A, let's use opposite over hypotenuse. Sine of 72 is equal to A over 8. Cross multiply, you get 8 times sine of 72. Let's see if this will work. 8 times 72 sine, enter. Point, this didn't work. Let me just try 72 sine times 8. There you go, 7.608. Now I gotta find, let's call this a side length. And remember, that's just gonna be half of it. So to find that, I have to do cosine. Let's do that over here. Cosine of 72 is equal to S adjacent over hypotenuse. Of course, my S's look like 8s. Good luck with that. So S is equal to 8 times cosine of 72. And you get about, let's see here, 72 cosine times 8 equals about 2.472. Okay, now remember that's half. So now let's fill out the formula. Area is equal to 1/2. Your apothem is about 7.608. N would be the number of sides, so that would be 10. And S, okay, got to be careful. I called this as like a half S, okay? I'm going to put like a half there just to remind us. 2.472, so I got to double that. So let's use about 4.9. That's with lots of decimals, okay? I know that won't really, good luck with that. All right, so when you put all of this in the calculator, you get about 186.4 units squared. It's a lot going on, okay? But you are expected to know these. So what I recommend, make everything an isosceles triangle. If you don't remember how to find any of the side lengths, you've got to remember to find use the trigonometry. Okay, we didn't actually answer everything. We got to find the perimeter. So the perimeter is equal to a side length, which we discovered was about 4.9. So 4.944, to be a little bit more accurate, multiplied by the number of sides. We have times 10, so just move that decimal over. 49.44, and this would be just units. Okay, so area and perimeter. Last page. Sorry about that. Wish I left more space. It's just some definition stuff. Just to kind of give you hints of what you could be using. To find the area of a regular n-gon with a radius r, you may need to first find an apothem or a side length. So using Pythagorean theorem, so you might have 1/2 that side length squared plus a squared is equal to r squared. So what you need, an r and an a, or an r and an s, obviously. Okay. What if you have special right triangles? Remember the 30, 60, 90, x, 2x, x squared of 3 to remind you, and 45, 45, 90 would be x, x, x squared of 2. Now, there was that third special triangle. It was the 15, 75, 90, but I really don't remember the sides. Trigonometry, remember, sine of theta is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. If you remember that acronym, SOHCAHTOA. TOA. All right, so let's see here. Here's our homework. There's our Common Core Standard. And I hope everyone's having a nice evening. Take care of yourselves.